All right, we're back in week 5 now of this remote learning. We also got the news last week that we are not going back. Not much of a surprise to me. It's unfortunate. I miss you guys. I miss being at school. But it is what it is. Last week we finished up radicals. We looked at radical equations. That pretty much wrapped us up with that. We're moving on to exponential and logarithmic functions. We've seen exponential stuff. We're seeing a lot of talk of exponential functions right now. How this virus is growing exponentially and all that. You can talk about flattening the curve and all that. The first half of the curve is an exponential graph. And once we hit the bottom end of it as well, kind of be going down exponentially as well. Ends up looking pretty similar to a parabola eventually anyways. But besides the point there, it's kind of a connection to what we're looking at now. But we got exponential and logarithmic functions. We're just going to look at the graph basics this week. So I got my lesson for you. There's a couple of things that I want you to be able to recognize in these graphs. And that'll be about it. I want you to be able to pull out some information. And that's what we got. We got a worksheet going along with it, similar to last week. And then your standard weekly survey. Hope you guys are doing all right. And here we go. So this slide is going to have everything you need to know for exponential functions. A lot of information on this slide, but this is the slide you want to have available to you when you're doing the worksheet or anything like that. So we got a basic exponential function. Notice it's the x minus h and then the plus k stuff. That shifts it left and right as the x minus h is left and right. The k is up and down. Same stuff as any other function we've ever looked at. I mentioned that with radicals in the last chapter right before spring break, right before we had to go remote. We were talking about graphs. And that's kind of the same deal here. A standard exponential graph is typically 2 to the x. This is just the smallest number that we can have. 1's not going to change anything because 1 to any power is just 1. So 2 is the smallest number that we can really have and tends to be our standard graph. But we're going to look in general here. Domain is going to be something I'm asking for, or not asking for in this one. You can plug in anything you want with domain or with exponential functions. It doesn't matter what you plug in. Negative numbers, fractions, radicals, positive, 0, whatever you want. We can plug that all in. We're bringing back asymptotes. Remember asymptotes? A horizontal asymptote is an imaginary horizontal line that the curve approaches but does not cross or touch. We're also going to be finding the y-intercept, where you just simply plug in 0 for x and solve. It's the most math we're going to have to do with this for exponential functions. You're also going to tell me if the graph is increasing or decreasing. So there's a couple ways we can figure that out that help us. If b is a number that's greater than 1, it's going to be increasing. I'll show you some examples in the next slide as well. If it's a number between 0 and 1, the graph is going to be decreasing. So like 1/2, 3/4, stuff like that. Now if a is negative though, so if there's a negative out front, it's flipped over the x-axis. If the graph flips, then it flips the increasing or decreasing as well. So that means if, like this 2 to the x, it's increasing right now, but then if I put a negative out front, I flip it, the graph becomes decreasing. It flips that idea as well. We'll see that happen, I think, once. Maybe once on the worksheet as well. There'll be 3 things I want you to be able to recognize. Finding the horizontal asymptote, finding the y-intercept, whether the function is increasing or decreasing left to right. Last slide again tells us everything we need to know. Just some examples of graphs and all that. Y equals 2 to the x, like I said, the most basic one we can have. We're going to have a horizontal asymptote at 0. We'll talk about how to find that again. We're going to have a y-intercept at 0, 1. We have that. You just plug in 0 in the x, so 2 to the 0 power is just 1. And then the graph is increasing left to right. Left to right, it's going up. Now, these two graphs tend to be, or not tend, they are the same. I'm going to be focusing on this left one, the 1/2 to the x. So remember here, the b is 1/2. That's between 0 and 1, so the graph is decreasing left to right. Still have a horizontal asymptote at y equals 0. That hasn't shifted. and then just another one here. So these two graphs, or sorry, this is the same, or the graph up top. This is the bottom graph is the same graph, just flipped. So it becomes decreasing, as I was mentioning on the last slide. Moving on, looking at some examples. I'll probably talk through a couple, but I have reasons on each of them. So we have a basic one here. F of x equals 4 to the x. First thing I want you to find is the horizontal asymptote. Horizontal asymptote is just y equals 0. Why or how? Horizontal asymptote from that slide is y equals k. K is just 0. There's nothing there. There's no up or down movement. So it's just 0, so y equals 0. That's it. Y-intercept is the next thing I'm asking for. Plug in 0 for x and solve. Remember here, anything to the 0 power is 1. So 4 to the 0 power is just 1, so 0, 1 is your y-intercept. C, is it increasing or decreasing? You can just give me an I or a D. That's why I have that in blue there. That's why I put it in blue there. I'm just going to type it all out because I can do that. But my how here, or why, if b is greater than 1, then the graph is increasing. Simple as that. All right, that's what we're looking for. Each of these slides has the how or why portion, how I got that idea. Hopefully that helps out when you're looking at the notes. Let's check out 2 and 3. Alright, again, y equals k is your horizontal asymptote. I have nothing hanging out there, so it's plus 0, so my horizontal asymptote is 0. My y-intercept this time is 9. I plug in 0 for x, I get 0 plus 2 in the exponent, so it's 3 squared, which is 9. And I have all that work there for you. This graph is increasing again, same reason as last time. Okay? Last one I'm going to fully mention everything on. Next one I'll mention one thing in the bottom. So our first one where we have a different horizontal asymptote. We have y equals -3 is our horizontal asymptote. This k value is -3 as I mentioned here on the how. Plug it in. 0, 1/2 to the 0 power. Anything to the 0 power is 1, so you have 1. And then -3 equals -2. So we're good to go there. We are decreasing in this one because 1/2 is between 0 and 1. That's what that's saying. So we have that. Next, last one. Last thing I want to mention here. Actually, let's just go through this quick. Y equals 5. Y equals k is my horizontal asymptote. 5 is just your horizontal asymptote. 4. Now here. Watch this idea here. It's -2 to the x. Think of your PEMDAS, your orders of operation. We do the exponent first, so 2 to the 0 power first is 1, and then we make it negative. Alright, so 2 to the 0 is 1. We treat that -2 out front, unless the -2 is in parentheses, which it's not. We treat that as a -1 times 2 to the 0 power, as I mentioned here. Watch that, please. Next, decreasing. Now, the b value being 2, we know the graph is increasing. But the -1 out front flips the graph, so now the function is decreasing. This is what I was talking about, where when it flips the increasing, decreasing portion as well. Watch this entire problem with that negative out front. Alright. Now matching. I'm going to keep the matching pretty simple. There is going to be a matching section on the worksheet. Just think about the horizontal asymptote, the y-intercept, and then increasing or decreasing. Kind of in that order for the most part. I'm just going to remove all these. On the matching section on the worksheet, I'm going to give you a couple of the answers and I'm going to tell you why, what my reasoning was for those. But like number 3 here, I have 3 to the x plus 4. My horizontal asymptote would be 4. So I said my answer is B. I look at the graph. I have a horizontal asymptote going through 4. That's kind of the first thing I look for with that just because it's something that shifts it up or down. So I look at that first, but a lot of these have a y or a horizontal asymptote of 0, so you have to go through that and think of other ideas as well, if it flips and stuff like that. All right. I am going to, for the first time, have to split this into 2 videos. So I'm done with the exponential stuff, so I'll stop it there. I'll do a second video with logarithmic graphs and all that. So it's just me being long-winded and talking a lot through this. It shouldn't be too bad. There's 2 slides you got to pay attention to.